Hi all, we'll go ahead with new model. Okay, so it's nothing but normalization. Okay, so this is very much important in all aspect of your higher studies, also placement everywhere. Okay, so this is the fourth model. Okay, so outline of this model is first we study informal guidelines for relation database. So that is how we have to informally we have to maintain some good relation database, how we have to make it. Okay, then formally what all things we have to do it, that will study it. Okay, so for that we will require as a functional dependencies. Okay, so their definition, inference rules, okay, equivalent set of functional dependencies. Okay, so those things we'll see it. Then actual normalization will see it. Okay, so basically we required as a 1NF, 2NF, 3NF, then BCNF. So still you have as a 4NF also, 5NF also, then general normal form also is there. Okay, so some different normal forms are there, so those normal forms will study it. Okay, so after that we'll see how to some properties of a decomposition, that will study. Then multi-value attribute related things and joint dependencies and inclusive dependencies, those things will study it. So lossless join or remaining whatever kind of different kinds of joins are there, so that also will study it. Okay, so one by one we'll take it. So there are total 12 major points are there in this model, so these all things will study it. Okay, so first is informal guidelines. Okay, so before going for this informal guidelines, so normally what will be happen is, so you'll be having the you are planning to prepare one data base. Okay, so for that, so you have to make a proper design. Okay, so how that will say as a this in whatever design you are doing, it's a good one. Okay, so with respect to two point of view, we can say it as a logical, and just with respect to storage point of view. So logical is nothing but here is nothing but user point of view, so how user will see it. And one more storage point of view is nothing but internally how we'll store it. Okay, so there are two kinds of good design. So so internally that is for a storing purpose, you may have as a b tree or b plus tree, all those things. With respect to user point of view, how attributes are related to each other, so those you have to group it in one separate group. Okay, then remaining should be there in one more different group, like that should be there. So like that you have to prepare a one design. Okay, so that's a normal will say as a database, relational database design. Okay, so relational database design in the sense, so whatever if you took a company database, so that is a normal you are saying as the entire thing, whatever things we studied previously for while studying SQL things. Okay, so those all things will come, all tables, all attributes, all things will come. So that is nothing but relational database. Okay, so how we will design that one, we'll see it. So in this, if I say it is only a relation, it means a normally in this model we will use the relation word. Okay, if I say the relation, it's nothing but a single table. Relational schema, it's nothing but a entire your database. Okay, for a one company or any example, whatever you are going to take it, that one. Okay, that is a relation schema will be there. Then a relation in the sense it will be a single table. Okay, and a tuple in the sense one row will be there. Okay, so normally we will consider it as a one row. Okay, so after that we'll study actually, that is after informal guidelines we'll study the formal guidelines by depending on the functional dependencies. So what is functional dependency, how it will be there, that we'll see it. Then depending on these functional dependencies, you will be having the 1NF, 2NF, 3NF, BCNF. Okay, so all those things we will derive it and we'll check it, is it there in which normal form. Okay, so then there are different forms are there, normal forms. So one by one we have to achieve it. There is first normal form, second normal form, third normal form. If you are there in third normal form, means by default you are the completed second normal form and first normal form, like that. Okay, so for this you have the formal guidelines for this one. Okay, so those things will study it. So first one, there is a informal guidelines. Okay, so in that informal guidelines we have four things. Okay, so here first one is semantics of a relational attributes. It says as a, so whenever you are giving a relation name, okay, there is a table name, normally we'll say it, a relation name or any attribute name, that should be a valid one, so that after reading that one only you should identify which kind of entity or which kind of relationship is there. Okay, So here we are saying is that whatever we are giving it, that should be a proper name should be there, and we have to make sure that different entities, okay, so different entities means, and different relations whatever will create it, for that you should not have the same attribute name. Okay, so for example, suppose I am creating a different entity of employee, okay, then department, then project. Okay, so we should not use as a name as a one attribute which will be there inside a department also, which will be there inside a project entity also, which will be there inside a employee also. So, okay, so like this common thing you should not use it, common attribute name you should not use it. Okay, so instead of that you can use as a e name, that is nothing but employee name. Okay, so d name you can use it, there is a department name. Then p name you can use it, there is a project name. So like that you have to differentiate. So a combination should not be there, and you have to try to avoid the same relation name also. Okay, so maybe sometimes you may differentiate only with respect to one spelling for a two tables. Okay, so you have to avoid those kind of things. And if you want to use a common attributes in between, okay, different relationships, that should be only foreign key should be there. Okay, so whatever foreign key is there, that foreign key only should be there inside between the different entities or different relationships. Okay, entity and relationship attributes should be kept apart as much as possible. Okay, so whatever entity or your relationship attributes are there, those names also you have to keep it different things. Okay, so here in detail, that is we have to say as this is informal first guideline says normally, that is design a schema that can be explained easily relation by relation. Okay, so here easily it has to identify what you want to do it. So the semantics of attributes should be easy to interpret. By seeing that one only, you have to easily analyze what is the designer's intention, and it should be easily known to the user also. Okay, so that kind of things you have tried it. Okay. Then this is one example. This is nothing but here if you have as a employee. Okay, so here we are given as a e name, ssn. Okay, date of birth. So this e name is not repeating anywhere. Okay, so different things you have to use it. Okay, so and here if you saw d number, this is a foreign key. Okay, and here in department, d name is there, department number is there, D manager is there. Okay, manager SSN. Okay, so this one as it is we are using it, so it's not a problem. Okay, so D number here if you saw, this is a foreign key, here is a primary key. So this is not a problem. Primary key and foreign key concept, you can use it. There is if it is a foreign key, you can use as it is attribute name. Okay, otherwise you have to avoid the giving the same name. Okay, and you should not have the same table names also. Okay, so you have to maximum times you have to avoid that giving the same table names also. Then next one is redundant information. Okay, so redundant information is nothing but unwanted some information you are keeping it. Okay, so it's a waste of memory you are doing it. So unwanted information or unwanted attributes you are grouped inside a table and you kept it. Okay, so these things will lead you to the update anomalies. Okay, so update anomaly in the sense there are three kinds of anomalies are there. Anomaly in the sense there is a problem. Okay, so three kinds of problems it will lead you. Okay, so first one is insertion anomaly, when it will lead. Okay, so while inserting something it will lead the some problem. And deletion anomaly, then modification anomaly. There are three kinds of problems it will lead it. So what all those things, will take one example. Suppose consider this is my relation, okay, or a table. My table name is emp underscore prog. Okay, so this is my relation is there. So inside this one, these are the attributes. Okay, so that is a employee number is there, project number is there, employee name is there, project name is there, then a number of hours that employee is working for that project. Okay, so these are the attributes, five attributes we have it. So suppose now, okay, so one inside one project. Okay, so suppose p1 project. Okay, consider the one project p1 is there. For that some 100 employees are working. Okay, so instead of p1, so after some time we want to change the project name. Okay, so project name I want to change it. So instead of p1, suppose I want to give as a p10. Okay, so how many entries I have to modify? So it is actually if you kept this one project name and project number inside a different table, so that time only one row you have to modify it. Okay, now 100 employees are modifying means to change the project name, so you have to modify 100 rows here. In this relation you have to modify 100 rows because 100 employees are there, they are working in this P1 project. Okay, so if I want to modify as a P1 to P10, okay, so 100 rows you have to modify it. Okay, so it's a overburden. So but finally you are changing the actual value of one project only, P1 to P10. Okay, but here 100 rows you have to modify it. If 1000 employees are there means 1000 employees are there and they are working for a P1 project only. Okay, so that time you have to modify 1000 rows. That will be overhead. Okay, so you have to avoid these kind of things. Okay, this is a update anomaly. So whatever value is there, if you want to change something, okay, so that time it will give you the problem. Okay, so it's a modification anomaly, we will say it. Okay, so this anomaly is nothing but modification anomaly. Okay, so then next one is insert anomaly, we'll see it. So same thing, same relation, we'll see it. Okay, so in this, suppose if I deleted or if you want to insert an employee. Okay, so if I want to insert an employee, so immediately what will happen is immediately he should have a project also. Okay, so directly you have to assign that project also. Okay, sometimes I am will recruit the employees, okay, but will not assign the any actually project only. Okay, so we'll train them, then we'll assign it. Okay, project. But now if you're recruiting the any employee, and directly here if you saw, you have to give the project number. Okay, so this is the overhead. Okay, so while inserting you have to give some value for project number also, project name also. This is the overhead. So this kind of anomalies will come. Okay, so you have to avoid keeping merging these kind of attributes. Okay, so or in reverse way we can say that I cannot insert a employee unless he or she is assigned a project. Okay, so it's nothing but we can't insert unless we give the one project name for that employee. Okay, so reverse of this one we can say it is a insert anomaly. Okay, so and here one more thing is deletion anomaly. So deletion anomaly is nothing but suppose one employee is working for one project. In that project only one employee is there. Okay, so one project number 10 is there, suppose. Okay, so for that one employee is working, xyz employee name he is working. Okay, so suppose I want to delete that employee information. Okay, so by default along with employee, project also will get deleted. Or reverse of that, if I want to delete that project information, so by default along with that employee information also will get deleted. Okay, so it should not happen it, because my intention is that time to delete maybe only project information. Suppose the project 10 information I want to delete it, I don't want that one in my database. So if I am deleting project 10 information, along with that employee information also is going. So normally we don't require that one. Okay, so we have to avoid this kind of combination of attributes. So this is a deletion anomaly. So this is the one kind of problem it will come whenever you are trying to delete any row. Okay, so the redundant things, that is unwanted attributes or unwanted any kind of columns, you should not merge it. Okay, so whenever you are merging it, there's it may be a wastage of storage also, and you will get the some kind of anomalies. Normally we'll say as update anomalies. In that three types are there: insertion anomaly, deletion anomaly, modification anomaly. So we saw these three. Okay, so one example. Now, so this is the in general we written, so whatever we are discussing here, same thing we written here, schema diagram. Okay, so two examples we written. So these are the these two represents the anomalies. Okay, so all three, insertion, deletion and update anomalies, are there in these things. Okay, so along with here some example values are also there, so these are the redundant. Okay, so if you saw here, normally what we have is a employee department, so employee name is there. Okay, so e name, so here ssn is there, their date of birth, address, okay, which department he belongs to. This is the information we have. So along with this one, if you saw here, so if you are keeping the department name also, department manager information also, so these are redundant. Okay, so we don't require to keep for all the employees here. Suppose I have 1000 employees here, so for 1000 employees no need to keep this one. If you saw here, research department has manager, this one, so kept as a department itself as on different table. So in that, if I kept as a department number, department name, and their manager, only one row is enough. Okay, so for research one row is enough, administrator one row is enough, two rows are enough total for instead of this one. So instead of this entire two columns, we can have only two rows in a one new table. Okay, so we have to avoid these kind of things. So like that, here one more example is there. There you have say e number and e name and p name are repeating. Okay, so these are the different kinds of anomalies it will produce it. Okay, so you have to avoid that one only. This is the guideline. Okay, so you have to avoid update anomalies. Third one, avoid the normally null values. Okay, so whenever possible, avoid which attributes which takes the null values. Okay, so maximum times you have to make sure that none of the attributes should take the null values. So sometimes we may have as a by default those attributes will take the values only, that is null values, because maybe we don't know the value of that one, it is unknown values. I think we already studied about null. Okay, so three kinds of will come. Okay, so sometimes we have to give it, but very rare case means it's accepted. So maximum times you should not have the null values in your database. Frequently null values whichever attribute is taking, that you have to place it in some different table only. Suppose if I have one xyz attribute, okay, frequently it's taking the null value, means that attribute you have to remove it from the any major table you have, that you have to remove it and you have to keep it in some other table only. Okay, so you have to avoid those kind of things. Then fourth one, spurious tuples. Okay, so normally what will happen is whenever you are making a table, okay, so normally you will be having some set of attributes. Normally you will try to split it. Okay, split it, and you will try to keep the different tables. Like here, whatever while discussing, we told as a here null values. If it is frequently is taking, you will keep it in some different table only. Okay, so while creating like this in a table, okay, so then while retrieving some data from the database, maybe you will use the join operation. Okay, so two or more tables you will try to join it. Then you will what you will do is you will fetch whatever data you required it from the user. Okay, so whenever you are doing that join operation, spurious tuples it should not generate. Okay, that is spurious tuples means erroneous tuples. Okay, that is your result itself is giving a wrong one. Okay, normally to avoid a spurious tuples we will do the join. Okay, so after join also, if you are getting a spurious tuples means in your database there is a problem. Okay, so that is lossless join, you have to do it. So whenever you are doing it, so unwanted extra things you should not get it. Okay, so here we'll see one example. One second. So suppose, okay, so here, so suppose I have one table. Okay, so in that I have ssn, project number, okay, number of hours he is working for this project, okay, employee name, project name, then location. Okay, so like this six attributes we have. So maybe because of some reason we want to split this one. Okay, so we are splitting it. So while splitting, suppose if I split it like this, okay, that is employee name and p location. Okay, I grouped these two, that is employee name and p location. If I grouped these two attributes in one table, then remaining attributes in another table along with p location. Okay, so one more extra along here, remaining are, that is ssn, p number, hours. Okay, then project name, these four along with that p location also. If I grouped these five, okay, so why we are using here these two is nothing but p location, both side is nothing but one side is a for the joining purpose. So normally we will use as a primary key, foreign key concepts. And here this is for the joining purpose. P location I'm using it. Okay, so here this is a primary key. Okay, so both together it's a primary key actually. So here it's a primary key, so here it will become as a foreign key. Okay, so in this table it will become a foreign key. Suppose if I divided like this table, okay, So what all values will be there? So whatever these values are there, that will divide and will keep it. So it will come like this. Okay. So employee name, it will come here. These three things. Project P location. These three things will come it. So whoever is staying. So here. So Smith P. Okay. So here project location. He is working for here. So he's working here. Okay. So then that is Bellary. Okay, so here Smith B. Then Sugarland. He's working for Sugarland. Also, it will come. Then English. So he will come as Bellary. Okay, so these three things it will come at. So along with that, your different attributes, whatever are there, that will come at. So these are the values we will get it. Suppose some any query is there which requires to join these two tables. Okay, in future, because you have to retrieve the values. So that time, if you require to join these two things, what will happen is, so here if I joined these two tables now, if you saw here, unwanted one row is getting here. Okay, so for example, while joining here p location to p location, you have to use it. So here Meller is there, this one joining with this one. Okay, so that is nothing but, so in this, in front of this row, there are, this row will come. Okay, so then this row will join with this one also. Okay, so it is two rows for here first row. Okay, then for here second row, one row will come, that is the third one, totally in resultant. Okay, then so in front of this one again two rows will come, here also it will join it, here also it will join it, so total 5 so 5 rows will get it. Okay, that is, so Smith, he is working in here p location this one. Okay, with SSN number 789. Okay, and he is working for 32 hours, 32.5 hours. Okay, then again second time again Smith, here he, it will be joined here. Okay, so his SSN number 45, like this it will come. Okay, then project number 1, then 20 hours he is working it. Okay, so if you saw this first row is joining with here first one and third one. Okay, so it's joining with these two. Okay, first one and third one. So here if you saw here, that is Smith actually, whatever we had actually our content for Smith, SSN number is 1 2 3 4 5 6 7 8 9. Okay, but here if you saw, we are getting something else only. So SSN number, we are getting something else. So this is unwanted extra result, erroneous result you are getting it. Like that here also it will come. Okay, so for this person, that is English, for this person you are getting something extra unwanted erroneous result you are getting it. So like this, whenever you are joining it, so you will get unwanted extra rows after joining only. Okay, okay, so you will get it. So what we have to do is, so whenever you are splitting it, you have to make sure that primary key, foreign key should be well known. Okay, and you have to divide, that is you have to split the table so that it should not generate the unwanted spurious tuples. Okay, so for that only we will be having the normalizations. Okay, different normal forms we will be having it. Okay, so this is the fourth guideline. That is something, but whenever you are joining it, two tables, unwanted or spurious tuples, you should not generate it.